let's understand the force diagram or free body diagram technique. This is a very important concept, free body diagram or force diagram technique or method. So what we do primarily in free body diagram or force diagram, over there primarily our intention is, that is, if we have a bigger problem, we break it into smaller pieces, we chunk it down. It is more or less, you can say that it is divide and rule. You break a bigger problem into smaller chunks, then you look at the smaller chunk, one chunk, and you find that if there is something wrong with this or what you can do about it, then you go to the second chunk, you try to find a solution to the second chunk problem, third, fourth, and so on, then eventually you find the solution to the whole bigger problem. Now in force diagram method or free body diagram method or technique, we have primarily 3 steps. The step number 1 is isolate the body, second is draw forces, and third is apply F is equal to ma, resultant force is equal to mass into acceleration. Let's take few examples to understand free body diagram, how it can be applied. Suppose we have 2 blocks. One is, this is 10 kg block, mass of this block is 10 kg, mass of this block is 5 kg. For ease of calculation, we shall be taking G as 10 meter per second square. In your examination or assignments, wherever it is, officially you have to give the answers, take G as 9.81 meter per second square only, not 10 meter per second square. You can take G as 10 meter per second square only if it is specified. For ease of calculation, we shall be taking G as 10 meter per second square, so that our main emphasis is primarily on the understanding of the concept rather than the calculations. So over here we have 2 blocks of mass 5 kg and 10 kg. You also know that is, when I say that is mass, mass is a scalar quantity. This is scalar quantity. When you say weight, weight is m into g, that is mass into acceleration due to gravity, and this is this unit of force. This is a force only. This is a force with which the earth is pulling all the objects towards its center, and this force is weight. This is mg, so obviously the unit is Newton only. The unit of force is Newton. So over here we have 2 blocks, 5 kg and 10 kg. Let's draw the force diagram for these 2 blocks. First step is isolate the body. So what we do is, that is, we slightly isolate these 2 blocks. Isolation doesn't mean, that is, we have separated them physically. We have not separated them physically. It's only, that is, we have created some space so that we are able to draw the diagram. That's all. So this is 5 kg and this is 10 kg. Let's first see what is the force which is applied by earth onto these blocks. Earth is going to apply a force of 5 m into g, that is mg. M is 5, g is, we have taken at 10 meter per second square. So this is 50 Newton earth is going to apply in this direction. Earth is also going to apply 10 into 10, that is 100 Newton mg onto this block. Earth will not say that is, I am going to apply a force of 150 Newton onto you, I am going to spare you. Earth applies a force equal to weight even on every single air molecule also. It doesn't spare anyone. So these forces, they are being applied by earth onto them. When earth applies a force onto them, then these blocks, they also apply a force on the earth, which is equal and opposite. To every action there is equal and opposite reaction. But right now we are not bothered what is the force these blocks they are applying on the earth. We are more bothered about these blocks. So that's why we are not showing, that is, what are the forces which are experienced by earth. We are showing, that is, what are the forces which are being experienced by these 2 blocks. Remember, in free body diagram method or force diagram method, we onto the every block or onto the body, we only show the forces which are being experienced by the body. Like in our earlier case, when we have said that is, when we push one hand against the other, then this is a curve like this. So in free body diagram, we'll show a force like this onto this. That is because this is experiencing force in this direction. We will not show onto this that force is being applied in this direction onto this. No. And when we draw the force diagram of this hand, this had experienced a force in this direction. So in free body diagram, we shall be showing a force like this. Similarly, this 5 kg experiences a pull in the downward direction by earth. So that is 50 Newton. This 10 kg mass experiences a pull in the downward direction, 100 Newton. Now 5 kg block is on top of 10 kg block. So as a result, this has a tendency, when earth pulls it, this has a tendency to push it downwards. We don't know what is the value of this force, and neither we are in a hurry to tell what is this force. We shall be more bothered about, that is, how to apply these steps, rather than jumping to answer and not being sure whether that is my answer is right or wrong. This applies a force F1 onto this. When this applies a force, when this pushes it down, then this will also push it up. To every reaction, there is equal and opposite reaction. F1, F1, equal and opposite. This applies it down and this pushes it up. Similarly, this 10 kg block pushes this surface with the force F2, and this applies a force F2. When suppose you are there, when you sit on chair, you push the chair down and this chair pushes you up. That's why you remain balanced. Now in force diagram of free body diagram, what is the advantage we have is, now we have separated these bodies and their affairs, they are separate. Into this life of 5 kg block, there are two forces, one is 15 Newton, the other is F1. We will not mix the two things. We will not mix. When we are talking about this block, we shall be only concerned about this block and the forces which are being applied onto this block, that is 15 Newton and F1. When we are speaking about this force, this block, that is 10 kg, in its onto this there are three forces, 100 Newton, F2 and F1. We shall be talking about these forces only. Whenever you draw a force diagram or free body diagram, please make these diagrams neat and clean. Clear diagram, they help you in your thinking process. A cluttered diagram, it confuses you more. So once this diagram is drawn, now let's get to the answer. Suppose someone asks, what is the force this applies onto this, or this, or what is the force 10 kg applies on 5 kg block, or these forces they have been asked. So now what we do is, we go to the third step, F is equal to ma. Over here we see, that is, if a person is here, he sees that is these two blocks, they are stationary, they are not moving, their velocities they are not changing. When the velocities they are not changing, then obviously the rate of change of velocity is 0, that is acceleration is equal to 0. When the acceleration is equal to 0, then obviously the resultant force has to be equal to 0. And right now we have only forces along the y-axis. If we take this as x-axis, this as y-axis, we see that is all the forces, they are only along the y-axis. So there is no need of right now talking about the forces along the x-axis, which is, there is no force along the x-axis. Now we apply F is equal to ma. Acceleration of this is equal to 0. If acceleration of this block is equal to 0, it means net force onto this, that has to be 0. It means F1 should be equal to 50 Newton. So F1 should be equal to 50 Newton. The upward force, it has to be equal to downward force. Had this force been greater than this force, suppose F1 is greater than 50, then this will start accelerating upwards. If 50 Newton is greater than F1, then this will start accelerating in the downward direction. This is neither going up nor going down. This is stationary over here. This is not accelerating. So that's why this force has to be equal to this force. Similarly, now coming to this 10 kg block, with 10 kg block, there are three forces which are associated. One is 100 Newton, F1 and F2. These three forces. And we see that is its acceleration is also equal to 0. This is also stationary, this is also not moving, the velocity is not changing, rate of change of velocity is equal to 0, acceleration is equal to 0. When acceleration is equal to 0, it means the net force has to be equal to 0. It means the downward forces onto this block, they have to be equal to upward forces. When we say downward forces, it is not on the lower surface or upper surface. Downward forces means directed downwards. So this is force is directed downward, this force is directed downward, and this force is directed upward. This is neither going up nor going down. It means that downward forces F1 plus 100 should be equal to F2. We can put the value F1 50 Newton over here. So 50 plus 100. So F2 comes out to be 150 Newton. We see that is how we have done the chunking. That is how we have broken this bigger problem into the small problems. They have not become independent of each other. What's the value we have got it over here? We have used it here and we have got, that is F2 is equal to 150 Newton. Even if we use common sense and we say that is what is the force this 10 kg block applies on this surface, suppose you insert your hand, then obviously the weight you are carrying is 10 plus 5 15 kg into g, that is mg. Total mass is 10 plus 5 15 kg into g 10 150 Newton. So obviously you will feel a force of 150 Newton onto your hand. That is the same thing, 150 Newton. If you insert between 5 kg and 10 kg, you are carrying a weight of 50 Newton. That is obviously 50 Newton. That is F1. Force between this and this block is 50 Newton. So this is how you can use the free body diagram method. Suppose in the same case, we have put this whole thing in a lift, in an elevator, and this elevator is going up with 2 meter per second square. This is accelerating in the upward direction. Now what happens is, the force diagram remains same. Now, when we apply F is equal to ma, we have isolated the bodies, we have drawn the forces. The third is F is equal to ma. Now, this person who is seeing these two blocks which are in a lift, and he can see it, this is a glass elevator, glass lift. So he sees that is this block when the lift is going up with 2 meter per second square, so it means this block is also going with 2 meter per second square acceleration, and the same acceleration is going to be observed by this 10 kg block. So this person sees that is this acceleration of this block is 2 meter per second square in the upward direction, and same is for this 2 meter per second square for this. So now because this is accelerating in the upward direction, it means net force, it has to be in the upward direction. It means F1 has to be greater than 50 Newton. So equation for this, because this is accelerating up, so net force it has to be in the upward direction. So what we do is upward forces minus downward forces. F1 minus 50 is net force. This stands for FR, that is resultant force or net force. Mass of this body only, that is 5 into acceleration. So F1 becomes equal to 60 Newton. Similarly for this is accelerating up. So what we do is upward forces minus downward forces. Upward forces F2 minus downward forces F1 plus 100 is equal to mass of this body only, that is 10 into 2. F1 we have put 60 over here, F1 we know that is 60 over here. So F2 minus 160 is equal to 20. So F2 comes out to be 180 Newton. Now let's say if this elevator had been moving downward with the acceleration of suppose 3 meter per second square. Now in this case, earlier we have taken 2 meter per second square going up. Now let's say it is going with 3 meter per second square in the downward direction. Now what is the forces F1 and F2? We remove this 2 meter per second square. This is 2 meter per second square. So now it is 3 meter per second square in this case, and for this also 3 meter per second square. Now this is accelerating in the downward direction. So equation for this is 50 minus F1 is equal to mass 5 into 3, because this is accelerating in the downward direction. So net force has to be in the downward direction. So downward forces minus upward forces, that is the resultant force, is equal to mass of this body into acceleration. For this is also accelerating down, because we are taking that is this whole elevator is going down with 3 meter per second square in the downward direction. So equation for this is downward forces minus upward forces, that is F1 plus 100, that is downward forces, minus upward force, that is F2, is equal to mass of this 10 into 3. We can solve these to get the answer. This was an elementary example, but primarily this is the essence, that is how we use FBD. This is the basic essence, how we apply free body diagram or force body diagram to solve the questions.